Butter is one of the most ancient and essential foods ever made by humans, used for cooking, baking, preservation, and flavor for thousands of years. Yet the way butter is produced today has evolved into a high-speed industrial operation where chemistry, temperature control, and mechanical force transform fresh cream into perfectly uniform blocks by the ton. What looks like a simple yellow slab is actually a carefully engineered emulsion, built for consistent taste, texture, and shelf life, and produced inside modern dairy factories that run almost non-stop. And today on the How Factory, we're going inside butter plants to see exactly how butter is made. From fresh cream to perfect blocks ready for supermarkets around the world, butter has a history older than written civilization. Early pastoral societies discovered that carrying milk in animal skins while traveling caused it to separate naturally. The constant shaking broke the fat structure and produced a thick, rich material that could be stored longer than fresh milk. Over time, butter became a staple across Europe, Asia, and the Middle East. It was prized not only as food, but as a way to preserve dairy through colder seasons. But while traditional butter was made in small wooden churns, modern demand requires factories capable of producing thousands of kilograms per hour with precision that older methods could never achieve. The modern process begins at dairy farms, where milk is collected daily from cows raised under strict animal health and hygiene standards. Fresh milk is cooled immediately to slow bacterial growth and transported in refrigerated tanker trucks to processing plants. At the plant, milk is tested for fat content, antibiotic residues, microbial load, and purity. Nothing moves forward without passing these tests because butter production depends on clean, stable, raw cream. Once approved, milk enters centrifuge separators. These machines spin milk at high speed, using centrifugal force to separate fat from skim milk. The lighter fat fraction becomes cream, while the heavier skim milk flows out separately. Butter factories may receive cream directly or separated on-site depending on facility design. The cream's fat content is adjusted to specific levels, often around 35 to 40% fat, to ensure consistent churning performance. Next comes pasteurization, one of the most critical steps in butter manufacturing. Cream is heated to destroy harmful bacteria and stabilize the product. Modern pasteurizers use plate heat exchangers that heat cream rapidly, then cool it just as fast. Temperature and time are carefully controlled. Pasteurization also affects flavor, so some specialty butters use different heat profiles to preserve richer notes. After pasteurization, the cream is cooled and stored in insulated tanks. At this point, some butter is made as sweet cream butter, meaning it is churned directly without fermentation. Other types, like cultured butter, undergo an additional step where bacterial cultures are added to the cream. These cultures ferment lactose and produce lactic acid, creating a tangier flavor and a more complex aroma. Cultured cream is held at controlled temperatures for hours until it reaches the desired acidity. Now comes a stage most people never think about: cream ripening and fat crystallization. Butter texture depends on the structure of milk fat, which changes depending on temperature history. Factories carefully chill the cream to specific temperatures so fat crystals form in a controlled way. This influences whether butter becomes spreadable, firm, or brittle. Getting this wrong results in butter that breaks apart, feels greasy, or spreads poorly. Once the cream is perfectly conditioned, it enters the churn system, the step that transforms liquid cream into solid butter. Traditional butter was churned slowly in wooden barrels, but modern factories use continuous butter-making machines. These systems can run non-stop, processing thousands of liters of cream per hour. Inside the butter maker, cream is agitated intensely. The motion breaks the fat globule membranes, causing fat to clump together. At first, the cream becomes whipped and foamy, then suddenly it separates into two phases: butter grains and buttermilk. This is the moment butter is born. The fat gathers into small granules while the remaining liquid becomes buttermilk. Buttermilk is drained away continuously and collected for other products such as baking ingredients, protein powders, or animal feed. Meanwhile, butter grains move into a working section where they are pressed and kneaded together into a continuous mass. Working is critical because it controls water distribution in the butter. Butter is a water and fat emulsion, meaning tiny droplets of water are trapped inside fat. The size and distribution of these droplets determine texture and shelf life. At this stage, butter may be washed with chilled water to remove leftover buttermilk, improving purity and shelf stability. Washing also helps control flavor, especially for butter meant for long storage. The butter is then worked further to achieve smoothness and uniformity. Now, salt may be added. Salted butter is extremely popular because salt improves flavor and extends shelf life by reducing microbial activity. Salt is added in precise amounts using dosing systems that ensure consistency. The butter is mixed thoroughly so salt distributes evenly without creating gritty pockets. Quality control at this point is constant. Technicians measure moisture content, salt percentage, fat levels, and texture. Butter must meet strict legal standards for fat content in many countries. Moisture levels must remain within limits to prevent spoilage and maintain consistency. If the butter is too wet, it becomes unstable. Too dry, and it becomes hard and crumbly. Once the butter reaches final specification, it moves to packaging. This is where industrial speed becomes obvious. Butter can be packaged in multiple formats: small retail sticks, wrapped blocks, or massive slabs for food service and industrial baking. The butter flows through stainless steel pipes into forming machines that shape it into exact sizes. For retail butter, forming machines cut butter into sticks or blocks and wrap them in foil or paper-lined packaging. Wrappers are designed to block light and oxygen, preventing flavor degradation. High-speed machines fold and seal wraps instantly, applying batch codes and expiration dates. For bulk butter used in bakeries and food manufacturing, butter may be pressed into large cartons or plastic-lined boxes weighing 10 to 25 kilograms. These blocks are cut with precision and packed tightly to prevent air pockets. Once packaged, butter moves into cold storage. Temperature control remains critical. Butter must remain cold enough to stay firm but not so cold that it becomes brittle. Warehouses maintain controlled refrigeration and track inventory carefully to ensure freshness. Distribution follows the cold chain. Butter is shipped in refrigerated trucks to retailers, restaurants, and export markets. Because butter is sensitive to temperature swings, logistics systems monitor conditions continuously during transport. Behind the scenes, butter factories also manage sustainability and efficiency. Cream and milk byproducts are processed into additional products rather than wasted. Buttermilk is used in food manufacturing. Heat recovery systems reuse energy from pasteurization. Water used in cleaning is filtered and recycled where possible. Modern dairy plants operate as interconnected systems where every output becomes an input somewhere else. What makes butter manufacturing remarkable is how it transforms a fragile liquid into a stable solid using controlled mechanical force. The entire process depends on controlling fat behavior at the molecular level. Cream must be heated, cooled, ripened, and churned under exact conditions. Even tiny changes in temperature can shift texture and spreadability, which is why butter factories rely heavily on sensors, automation, and constant testing. From ancient nomads discovering butter by accident to modern continuous butter makers producing tons per hour, butter has remained a foundational food. But the scale has transformed completely. Today, butter production is a fusion of tradition and industrial engineering, preserving the same basic principle while delivering a product consistent enough for global supermarkets. From farm-fresh milk to centrifuge separation, from pasteurization to controlled fat crystallization, from churning and working to high-speed wrapping lines, the journey of butter is a hidden industrial process behind one of the world's most familiar foods. And that is exactly how butter is separated: pasteurized, ripened, churned, worked, salted, formed, wrapped, and shipped. Transforming fresh cream into perfectly smooth blocks used in kitchens worldwide. Thanks for watching The How Factory, where we reveal how the world really works. Don't forget to like, subscribe, and join us again for more deep dives into the farms, factories, and systems behind the foods we use every day.